In this video, we will calculate the number of significant figures in a number. Now, this is important when you do a math problem. Okay, you don't want to write every single number that's in your calculator because it can go on and on and on forever. And, some calculators will give it up to 9 digits. Some calculators could give up to 100 digits. Becomes a point where it becomes useless and you need a cutoff. Significant figures provide that cutoff. One thing is the only issue with significant figs has to do with the zeros and has to do with the decimals. So going in part A, there's something called the Atlantic Pacific rule if you want to learn that. But let me just go over this one by one using the examples. So first of all, part A, is it a decimal or not? The answer is yes. So if it's a decimal, anything to the right, first of all, that 6 is a real number. So anything to the right of that real number is significant, and that also includes zeros. So this has 1 sig fig. Okay, as an example, let me modify this. If I have 0.0060, okay, that's 2 sig figs. Okay, any 0 to the right of a real number and to the right of the decimal, that is considered significant. How about part B? All right, a 0, remember issues come with zeros. That's where we get our little headaches here. A 0 that's between two real numbers. Obviously 6 is real. 0, okay, that's the issue. 5 is real. The 0 is flanking, is guarded by two real numbers. So that's considered significant. So that's 3 SF, 3 sig figs. All right, how about 60.5 milligrams? Same situation here. This is going to be 3 significant figures. That's zeros between two real numbers. Same thing with this one. It's a decimal point, and that's going to be 4 sig figs, okay? Because the 0 is between two real numbers. 6 is obviously real. 0 is flanking two real numbers, a 6 and a 5, and that 5 is real. Exponents, I tell students, is the easiest. You just take the number that is to the left of the multiplication symbol, and that is significant. So that is 3 significant figures. Anytime you see exponents like you do here, just count the number to the left of the exponent, and then you're good. And 60 meters, those are whole numbers. Those are exact numbers. So we have no sig figs. So this is a point of confusion for a lot of students. But if you have something that's exact, where there is no cutoff, you see there's no rounding here. And really, there's no rounding here. If there is, it's really ambiguous. So anytime you have a whole number, it's ambiguous because it's exact. There is no rounding. And if you, as in the case with 60 meters, if you round, you don't know how it got rounded to. Exact numbers will not carry any significant figures. They're just ambiguous.